Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of line in R3. So as per part A, determine the parametric equations for each of the following lines. So we are given these two equations in symmetric form and we have to convert the symmetric form to parametric form. So let's start with the first equation. So we have to use a parameter to change this symmetric form to parametric form. Let's assume the parameter for this equation is m. So we have to equate each fraction in the symmetric equation to m and then solve for x, y, and z. So let's start with the fraction with x. X plus 6 over 1 is equal to just x plus 6. Now we can isolate x by subtracting 6 from both sides. So this is the x parametric equation. Now we can do the same analysis for the y fraction. We can cross multiply the negative 1. Now we can add 10 to both sides. So this is the y equation of the parametric form. Now we can analyze the z fraction. Z minus 7 over 1 is equal to just z minus 7. Now we can add 7 to both sides. So this is the z equation of the parametric form. Now we can write the three parametric equations together. So this should be the final answer for the first equation. Now we can analyze the second equation. In this equation, the z equation is already in parametric form. So we just have to convert the x and y parts into the parametric equation. And for this equation, we can use the parameter n. So we should isolate x and y using this parameter. X plus 7 over 1 can be written as just x plus 7. Now we have to isolate x, so we should subtract 7 from both sides. So this is the x parametric equation. Now we can write the y parametric equation. We can cross multiply the negative 1. Now we can add 11 to both sides. So this is the y parametric equation. We already have the z equation in parametric form, so now we can write the three equations together. So this should be the final answer for the second equation. So we are done with part A. Now we can answer part B. Determine the angle between the two lines. The angle between the two lines is equal to the angle between their direction vectors. And in the given symmetric equations, the components of the direction vector are in the denominator. The components of the direction vector of the first line are 1, -1, 1. So these are the denominators in the symmetric equation. The components of the direction vector of the second line are 1, -1 and 0. So we get 1 and -1 from the denominators of the x and y parts of the symmetric equation, and the z component of the direction vector is 0 because the z part of the equation is not written in symmetric form. Now we can find the angle between these two direction vectors, and for that we should use the dot product equation. We can use the vectors m1 and m2. For the magnitude, we should square the components of the vector, add the squares, and apply square root to the sum. Now we can do the dot product on the left side. So we should multiply the x components, y components, and z components. On the right side, 1 square plus -1 square plus 1 square is equal to 3. 1 square plus -1 square plus 0 square is equal to 2. Now we can simplify the expression on the left side. Now we can divide both sides by square root of 6. Now we can do the inverse of cos. Now we can evaluate the inverse of cos. So I got almost 35.3 degrees. So this is the angle between the direction vectors, and this should be the angle between the two given lines. So this should be the final answer for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.